Assalamu alaikum. Today we are going to solve February-March 2023 paper 1 variant 2. Code is 9709. This is P1. Okay, in this paper our first question is a line has equation y equals 3x minus 2k and a curve has the equation y equals x square minus kx plus 2 where k is a constant. Show that the line and the curve meet for all values of k. So this is simple question. We have to equate both equations and then try to form a quadratic shape. So bring all the values on one side, and now here I'm taking x as a common. Now my a is 1. Actually the quotient of x square is always a, and the b is minus bracket k plus 3, and c is the whole constant value. There is no variable like x. So our c is 2 plus 2k. Now I'm going to use the discriminant b square minus 4ac. So my b is minus bracket k plus 3 whole square minus 4 times 1 times c is my 2 plus 2k. Now simplify this. The square of minus is plus, and use the identity a plus b whole square for k plus 3 whole square. So this is k square plus 6k plus 9 minus 4 going to multiply with the bracket 2 plus 2k. So now further simplify this. So this becomes k square minus 2k plus 1. Now it's a pure quadratic form. So 1 times 1 is 1. Make factors of 1. So we don't have factors of 1. Only 1 into 1 is the factor for 1. So I can use this in the middle. It's midterm breaking. So take k common. So I have two brackets same with k minus 1. So now look, this is if I equate it with 0, or I can say that k minus 1 is 2 times, so I can write it whole square. So use any value for k. Let's say k equals 2. So 2 minus 1 whole square is 1 square, which is greater than 0. Now I'm going to take negative 2 in place of k. So my result is minus 3 whole square, which is 9, and 9 is also greater than 0. It means that whatever value I use in place of k, that would be greater than 0. So I can say it means b square minus 4ac is greater than 0. So the line and the curve meet for all values of k. In question number 2, a function f is defined by f of x equals x square minus 2x plus 5 for x is a member of real numbers. A sequence of transformations is applied in the following order to the graph of y equals f of x. To give the graph of y is equal to g of x. Stretch parallel to the x-axis with the scale factor 1 over 2. Reflection in the y-axis, and then stretch parallel to the y-axis scale factor 3. Find g of x, giving your answer in the form ax square plus bx plus c, where a, b and c are constants. So first of all, write this f of x in name of y. So it becomes y equals x square minus 2x plus 5. So stretch parallel to the x-axis. So scale factor is 1 over 2, so we have to use 2. So you multiply 2 with x. First with x squared, then with 2x. So it becomes 2x whole square, and then 2 multiply by 2x, and then write 5. Okay, now reflection in the y-axis. So definitely the x coordinate becomes negative. So you write negative with x. So write minus 2x whole square minus 2 minus 2x plus 5. Then comes the stretch parallel to the y-axis with scale factor 3. So you multiply the whole equation by 3 like this. So now simplify it and you will get y equals g of x. First simplify the bracket inside and then multiply 3 with whole values inside the bracket. So this is our g of x. Question number 3. A curve has equation y equals this and a point is moving along the curve. Find the x coordinate of the point on the curve at which the x and the y coordinates are increasing at the same rate. Alright, so this is our equation. We have to find dy by dx. So bring down the power 2 and subtract 1 from 2 and then differentiate inside the bracket. Now simplify everything. So it becomes 3x plus 1 over 10. I am equating it with 1. Why I am equating it with 1? Let me explain this for look. Y equals 1 because x and y coordinates increasing at the same rate as told in the question. And it happens only when y is equal to x. Now differentiate y is equal to x equation. So I'm going to write dy by dx equals 1. The differentiation of x is 1. So dy by dx is the gradient. So that's why I am equating 3x plus 1 over 10 equals 1 because 3x plus 1 over 10 is differentiation, is dy by dx. So from here now simplify this to find out the value of x. So your x is 3 and you got the answer. Question number 4. The circumference around the trunk of a large tree is measured and found to be 5 meters. After 1 year, the circumference is measured again and found to be 5.02 meters. In part A, given that the circumferences at yearly intervals form an arithmetic progression, find the circumference 20 years after the first measurement. Okay, this is, I'm going to write the sequence like 1, 2, 3 and the nth term. My first is my A. Because he said arithmetic progressions, my second term is a plus d and my third term is a plus 2d and my nth term is a plus n minus 1 times d. A is always the value of first term and d is always the common difference. So my A is 5 and my difference is 5.02 minus 5. So 0.02 is my difference. So term 20 means we will use term 21. So a plus n minus 1 times d. So in n we have to use 21. So because 21 minus 1 makes 20. And you write difference d 0.02. Now this is our term 21. So now simplify it. You get 5.4. B part, Given instead that the circumferences at yearly intervals form a geometric progression, find the circumference 20 years after the first measurement. So in geometric progression, my first term is A, my second term is AR, and my third term is AR square, and my nth term is AR n power n minus 1. So here my A is 5 and my R is my common ratio. So I have to divide 5.02 by 5. So I will get R 1.004. So my term 21 is AR n power n minus 1. So A is 5 and R is my common ratio, which is 1.004, and power n minus 1 means 20. N is 21 and minus 1 makes 20. So use your calculator and get the value 5.42. In question number 5, coordinate of point A is given and B lie on the circle with center -2, 5. The line AB has equation this. Find the coordinates of B. Alright, so I'm just roughly drawing it to make it clear. This is my diameter and center is -2 and 5. The coordinates of the center are given, and let me make this radius and write A on the circumference and its coordinates given. Somewhere write B here. So how to find coordinates of B? So this is xy. So you write x1, y1 with A and x2, y2 with the coordinates of center. I mistakenly wrote x2, y2 on the coordinates of B. So now try to find out the distance of center O and A. So x2 minus x1 whole square plus y2 minus y1 whole square whole under root. So put the values carefully inside and then solve it. So this is your radius actually, square root of 130. Now equation of circle, x minus x1 whole square plus y minus y1 whole square equals r square. So now put the values in. So x minus, so it becomes plus because you have got -2 whole square, and then y plus 5, so plus minus makes minus. So radius is r squared, so you write just 130 because the power 2 will remove the sign of square root. So this is your first equation and this is your second. Now 1 into 2, equation 1 goes into 2. No, okay. Actually, equation 2 will go into equation 1, where you see y is written in the circle equation. So open x plus 2 whole square, like the identity x square plus 4x plus 4 plus, now in y you write -2x plus 26. Okay, this is again a mistake. It's not 21, it's 26. So you open it and you simplify this. Now factorize it. Factors of 63 are 9 into 7. Use -9 -7 in the middle. So you get this value. So x equals 7 and x equals 9. So 7 is already there in the coordinates of A. So leave it. and so x equals 9 must be the x coordinate for B. So now use this x equals 9 to get the value of y coordinate. So coordinates of B are 9, 8. Question number 6. In the expansion of this, it is given that quotient of x power 4 divided by quotient of x equals 3. Find the possible values of the constant a. So this is a plus b power n. So I'm going to use the specific term formula. So TR plus 1 equals NCR a power n minus r times b power r. So my n is 7. So I don't have r. So we will try to find out the value of r. So a is over x over a power n minus r means 7 minus r, and times b is over a over x square whole power r. Okay, now collect the x terms to find the value of r. So look, my 1x is x power 7 minus r. I'm ignoring a. And in second, my x, if you x is, there is x square written. So bring up the x square in the numerator, so it will become x power minus 2, and when it will multiply with the r, which is outside the bracket, it requires the shape x power minus 2r. Now bases are equal, power must be added, so x power 7 minus r minus 2r, which is x power 7 minus 3r. Now I'm looking for the quotient of x power 4. So equate this with x power 4 to get the value of r. So I can write x power 4 equals x power 7 minus 3r. So bases are same on either side of this equal to sign. So I can write 4 equals 7 minus 3r. From here I can get the value of r, which is 1. Okay, now I can use back in the main equation to find out the coefficient of x power 4. So look, in r I'm going to write 1. So 7c1 is 7, x power 6 a power 6 times. Now I'm going to simplify all this. So I get 7a power minus 5. Now let us try to find out the coefficient of x. To find out the coefficient of x, first we are going through the same method we used to find the value of r. So here again the value of r would be different. So x power 1 equals x power 7 minus 3r. So here 1 equals 7 minus 3r. Our r is 2. So now use this r2 to find the coefficient of x. 7c2 x over a whole power 5, and then a over x square whole power 2. Now 7c2 is over 21. Simplify all this. So 21a power 3. So now divide it. So 7a power minus 5 divide 21a power minus 3 is equal to 3. So now you will get, after simplification, a equals plus minus 1 over 3. This is your answer. In question number 7, by first obtaining a quadratic equation in cos theta, solve the equation tan theta sin theta equals 1 and theta is less than 360 greater than 0. Okay. So tan theta sin theta equals 1. So tan theta I can write sin theta over cos theta times sin theta equals 1. So sin squared theta over cos theta equals 1. So sin squared theta equals cos theta. So the identity sine square theta plus cos square theta is equal to 1, and here if I make sine square theta as a subject, can I write 1 minus cos square theta? So use this 1 minus cos square theta in place of sine square theta. So now everything goes on the other side. So it becomes cos square theta plus cos theta minus 1 equals 0. And this is a pure quadratic form. So a is equal to 1 because we cannot make factors. B equals 1. The quotient of cos theta is 1. And c is equal to minus 1. Now use the quadratic formula. So instead of writing x is equal to, you can write cos theta is equal to, you are dealing with cos theta, minus b plus minus b square minus 4ac whole over 2a. So now put the values in it carefully. So you get 1 plus and 1 minus value. 1 with plus and 1 with minus. So this is minus 1.61. So look, cos theta equals 1.61, so cannot be more than 1 because sine and cos remains under 1. So you cross it. Use the first value 0.68618. So find out the basic angle. Theta is equal to cos inverse of 0.618, which is 51.8. So our cos theta 0.618 was positive. So look where cos theta is positive in the 4 quadrant A, S, T, C. So in the first quadrant cos is positive, and in the fourth quadrant cos is positive, and our basic angles always make with the x-axis. So in the first quadrant our basic angle 51.8, and that is equal to our theta, which is required. And for the second you have to subtract 51.8 from 360. So we get 308.17. So this would be our final answer. So round it off to 1 decimal place. In part B, show that tan theta over sin theta minus sin theta over tan theta is equal to tan theta sin theta. Okay. In place of tan theta, I am going to use its identity, which is sin theta over cos theta. So tan theta equals sin theta over cos theta. So I am going to use this sin theta over cos theta whole over sin theta minus sin theta over, now tan, instead of tan theta I am going to write sin theta over cos theta. Now one by one simplify this. Sin theta over cos theta divided by sin theta. So you know how to do this. This becomes sin theta over cos theta. Divide changes into the sign of multiplication and take the reciprocal of sin theta, which is 1 over sin theta. And now cancel 2 sin thetas. So we got 1 over cos theta. We can write cos theta here. Now do the same thing here with the second fraction, sin theta over cos theta. Actually sin theta divided by sin theta over cos theta, and now change everything. Divide change into multiply, and sin over cos will change into cos over sin. Sin and sin gone, just cos of theta is left. So here we can write cos theta here. So 1 minus cos square theta over cos of theta. I am taking the LCM here. So in place of cos square theta, I can write 1 minus sin square theta. Now 1 minus 1 plus sin square theta over cos theta. So plus 1 minus 1 gone. So sin square theta over cos square theta. It means there are two sin thetas written. So we can split it, like we can write sin theta into sin theta over cos theta. It's the same thing. So sin over cos is tan. So we can write sin theta tan theta, or tan theta sin theta is the same thing, which is the right hand side. So it's shown. In our question 8, the diagram shows triangle ABC in which angle B is a right angle. The length of AB is 8 cm and the length of BC is 4. Point D on AB is such that AD equals 5. Sector DAC is a part of circle with center D. Find the perimeter of the shaded region. So to find the perimeter of the shaded region, we have to find out the length AC and the arc AC, length of the arc AC. So start with the right angle triangle. So DC equals 5 centimeter. Why? So you should know one thing, that if a right angle triangle is there and its perpendicular and base is 3 or 4 written, so hypotenuse will be always 5. No need to use a Pythagoras theorem. It is a known fact. So straight away you can write 5. So we got the length DC. So DC is also radius. So now try to find the angle D, BDC. So you can use any basic trigonometrical ratio, either sine, cos or tan. So I use cos here, base over hypotenuse. So cos theta equals base over hypotenuse, and theta is cos inverse of 3 over 5, which is 53.13. And if I subtract it from 180, I will get the angle ADC, this red one. So subtract it from 180, so 126.86, 126.9. So now opposite to D is my small d, the length AC. Opposite to C is my small c, the length AD, and opposite to capital A, the small a, that is the length of DC. Why I am writing this? Because you should know that included angle triangle, to find to work with this angle, you have to use cosine rule. What is included angle triangle? Included angle triangle are those triangles in which the length of the arms of the known angle are given. Like my known angle was 126.9 and its length, the length of its arms were DC and AD, and both were known. So this is purely an included angle triangle. So cosine rule will help me to find the length AC. So how to write its formula? Very simple. Because I'm going to find out small d, which is the length AC, so start it with d square. So A and C are left in this triangle, so you write a square plus c square minus then 2, both A and C multiply, and then cos of 126.9. Now place the values in this and carefully solve it. So my D is 8.94. Now let's try to find out the arc AC. So I'm going to use theta over 360 into 2 pi r. The arc length AC, theta over 360 into 2 pi r. So theta is there, 126.9 over 360 into 2 into 3.142 into radius is 5. So my arc length is 11.07. So now you add both of them. Add the value of AC and the arc length AC, and you will get the perimeter of the shaded region. Find the area of the shaded region. So area of sector minus area of triangle, and that is equal to area of the shaded region. So area of sector is 1 over 2 r square theta, or theta over 360 into pi r square. So I'm going to use theta over 360. So this is my value. And now area of triangle ADC, because it is included angle triangle. So to find the area of included angle triangle, we always use 1 over 2 into side into side into sine of theta. So everything is with us. Sides are 5 into 5 and sine theta is 126.9. Use a calculator and you get this value. Now you can subtract 9.996 from 27.68 and you will get the area of the shaded region. This is your answer for part B. Question number 9. The function f is defined by this. X is less than or equal to -1. State the range of f. So to find the range of f, you can place -1 in x and then the range will be there. Now -1 square and +1 are simplified. So this -1 gives you the range. Find an expression for f inverse of x. So you let f of x equals f of x equals y. So now you can write this in the name of y equals 3x square plus 2. After writing this, you have to make x the subject. So 3x square equals 2 minus y. So x square equals 2 minus y over 3. Now remove the x square, so take the square root on both sides. So x equals plus minus 2y over 3. Now you can write, you have already made x the subject, so you can now write f inverse of x equals plus minus 2 minus, replace y with x. So 2 minus x over 3 whole square root. So this is inverse. In part C, function g is defined by this. Solve the equation f of g of x minus g of f of x plus 8. So it's a composite function. So you can write g of x, the function g of x, into the function f of x. So f of x is your minus 3x squared plus 2. So you have to write g of x, which is minus x squared minus 1, into the function of f where you see x. So you write minus 3. In x square, you have to write the whole g of x. Now you simplify it, use identity. Now multiply minus 3 inside the bracket. Now go for g of f of x. Now this time you have to write the f of x, the whole function, into the function of g of x. Now simplify this. I am using a minus b whole square, the identity. Now minus this plus 8 equals 0. Now we have to further simplify, open the bracket, signs would be changed, and now like terms would be handled. X power 4 would be handled. Now x squares, and then the constant values. Now take, you can further simplify it by dividing 6. It becomes smaller. Now make x square as, give it a name as p. So it becomes, x power 4 becomes p square, and 3x square becomes 3p plus 2. Now use the midterm breaking, factorize it. So you got these factors. P equals 1 and p equals 2. Now replace p by x square. It means x square equals 1 and x square equals 2. So you got two values plus minus 1, and here you got two values plus minus 1.41. So because x was less than equal to negative 1, if you remember, so take x equals minus 1 and x equals minus 1.41 and forget about positive signs. So these two would be the answers for this part. Question number 10. At the point this, on the curve gradient is this minus 3 over 2, it is given dy by dx is this, where k is a constant, show that k is equal to minus 2. Alright, so dy by dx is given. So this should be equal to minus 3 over 2. From here now simplify it. Put x4 and now simplify it. So my k equals minus 2. And this is shown. In part B, he says find the equation of the curve. So dy by dx is given, so I have to integrate it. I have to go backwards. So integrate x power minus 1 over 2 minus 2 dx. So this is y equals minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1 minus 2x plus c. So this is x power 1 over 2 over 1 over 2 minus 2x plus c. So this one, the denominator 1 over 2 will become 2, and x power 1 over 2 becomes square root of x minus 2x plus c. Now place the values of x and y to find out c. So write -1 in y and 4 in x, and now then solve it for c. So c equals 3, and your equation is ready. Y equals 2, x under root minus 2x plus 3. Find the coordinate of the stationary point. At stationary point, dy by dx is always 0. So equate dy by dx, which is given, to 0, and now simplify it. So x is equal to 1 over 4. So this is the x coordinate on the stationary point. Now put this value in the main equation to get the value of y. So the equation you just found out, write down 1 over 4 in x and then simplify it. So here you get the value of y, which is 3.5 or 7 by 2. 3.5 is actually 7 by 2. So your coordinates are 1 over 4 comma 7 by 2. In part D, determine the nature of the stationary point. So you have to take derivative of the first derivative, means second derivative will decide the nature of the point. So your first derivative is already given, x power minus 1 over 2 minus 2. So you write d square y over dx square. Now differentiate it again. Minus 1 over 2 minus 1. Your minus 1 over 2 will come down first, and then subtract 1 from the power minus 1 over 2, which will become minus 3 over 2. And minus 2 is 0, no differentiation of minus 2. Now simplify this, put the value of x in it, 1 over 4, and further simplify this. So your answer is minus 1 over 4, which is less than 0. So it means it's a maximum. The nature is maximum. Question 11. The diagram shows the curve with equation this, and the points A and B coordinates are given, lie on the curve, and the equation of the line AB. So this part is very easy. Just find out the gradient, y2 minus y1 over x2 minus x1. So your gradient is 1. Now use y minus y1 equals m x minus x1. You can pick any one out of these two. I used the coordinates of A. So you write 2 in y and 5 in x. And now simplify it. So your equation is y equals x minus 3. In B part, find the volume of revolution when the region between the curve and the line AB is rotated through 360 degree about the y-axis. So this portion, first we will find out the volume of this portion. Actually not first, you can, let me color the green color, this one. This whole portion, volume of this whole portion minus the volume of the red line portion will give us the volume of this shaded portion, the main diagram. So how to do this? So y equals, because it is going to revolve around the y-axis, so pi x square is our formula. So I'm going to use equation of the straight line, I just have made y equals x minus 3. So I will make x the subject, y equals x minus 3 and x equals y plus 3. I will use this y plus 3 and then whole square dy. Limits are from minus 1 to 2. Now first open it according to the identity a plus b whole square. So this becomes y square plus 6y plus 9 dy. Now integrate, keep the pi which is constant at one side. So this y square becomes y3 by 3 and 6y becomes 6 into y2 over 2 and then 9 becomes 9y. So this is the integration. Limits are from minus 1 to 2. Okay. Now put the upper limit minus lower limit. First let me further simplify it, because 6 is going to be divided by 2. Now it's 3y square plus 9y. Limits from minus 1 to 2. Now I will place one by one. First upper limit in y's and then minus. I will place minus 1 in y's. So keep pi outside, upper limit. So 2 power 3 over 3 plus 3, 2 power 2, then plus 9 times 2. So this is my upper limit. Minus lower limit. Minus 1 power 3 over 3 plus 3 into minus 1 power 2 plus 9 into minus 1. Okay, now use your calculator very carefully and you will get pi times 117 over 3. So this is my first portion, which was green, and my volume of the red portion, let us work with that. Y equals pi integral minus 1 to 2 x square dy, and my equation is, the equation of the curve is x square equals y square plus 1 dy whole square. So now open this, same like a plus b whole square, so it becomes y power 4 plus 2y square plus 1 dy. So now integrate it. So y power 5 over 5 plus 2y3 over 3 plus y, and limits written. Now upper limit minus lower limit, very carefully. This is lower limit. Now use your calculator and find out the value. So I corrected the mistake. So this is 234 over 15. Now the first one, pi times 11703 minus pi times 234 over 15. So your answer is 223 whole 2 over 5 pi. So that's it. My number is this, and any inquiry, you can contact me on my WhatsApp. This is my WhatsApp number. Thank you so much.